Hey, so here after that animal, we are trying to detect another animal, which is hyena. Here, tiger. So sometimes camera contains only this much of image, but still it is able to detect that it is a tiger. And then this is elephant. Yeah. So this is the TensorFlow Lite API. Further, I added this um, working of VGG16 model, which consists of 16 convolutional layer. I have attached this YouTube video here. Then moving forward to our second task, which is identify their movement. So identify whether the animal is running or not. So you must have heard about this uh, algorithm. It's called YOLO, and it means you look only once. It is used for object detection. So basically this algorithm in this algorithm we take the image and then we divide it into a grid of 19 by 19, um, and then um, so each grid is responsible for predicting 5 bounding boxes. So this will give us 1805 bounding boxes. Since for each grid we are calculating 5 boxes, so this is a elephant. In the next step it will be much more clearer. So so here you can see. So so for the elephant here we are calculating 5 bounding boxes, and then we remove all the bounding other bounding boxes which doesn't contain animal, or which contains only the part of the animal, and this process is called as non-max separation. So as you can see here, there is only one bounding box right now. So how to detect the motion? So in this next frame, calculate the change in the bounding box, and if there is a change, then it is considered as an object in motion. The following algorithm demonstrate this yellow algorithm. This is a YouTube video for that, and that's how we calculate whether the animal in is in motion or not. So moving forward to the next step, so let's move to the results. So here, um, you can see, as I mentioned before, this is a metric which shows the accuracy of different models. So VGG model here, it shows the top accuracy. Here this is identification metric which shows the accuracy of different models. Here ResNet are working a little good, but since we used VGG for image classification, we are going to use it. We use the same here. So one of the benefit of this classification is that it eliminates the need of human to label the images. So by harnessing the threshold mechanism, um, we can I mean we can perform some filtering. Then we can increase the accuracy of classification to 96.6%. And further we can for the other small camera based project, we can use the concept of transfer learning. So this model is already trained, we can transfer this learning to the another model. um, then let's move to the next step. So challenges here, the one of the biggest challenge is detecting the animals and categorizing them is different in different lighting conditions, um, such as which is affected by weather, shadows, and weather can make the information extraction task even harder. So for example, it's raining, then it's difficult to identify animal correctly. So the long distance animals are also difficult to detect since the model is trained with the images wherein the animals are closer. Yeah. So let's move to the future scope and conclusion. So here I did some feature scope and conclusion. So um, An effective deep learning technology can save tremendous amount of time for biology researchers, ecologists, and wildlife photographers by detecting and identifying the state of an animal. In particular, for animal identification, this system saves almost 99% of manual labor while maintaining the same accuracy level of human in detecting the animal, as I mentioned before. So in future, if an animal is in motion and chasing another animal, then using GSM and a camera sensor can inform the wildlife researcher about the incidents so that they can record this incidents in much better way. So I did some bibliography. I did some references here, and finally after that I did a quiz. It's a short quiz. So which algorithm is used to uh, is used for object classification and identification, which is innate. So answer is correct. Okay, now this is really interesting. This is my favorite part. So do you know this guy on the left side? Um, so there are three hints over there. Can you guess that? Okay, so this guy is Timon from the Timon and Pumbaa series, but a lot of people don't know which animal is it. So on the right hand side, this is the actual image of that animal. Um, Here, so now we can watch. Our model can classify this animal. Let's see. So let's see. Whoa! You can see now it's a meerkat. It's it's an African milk meerkat specifically, but it's classifying that. So it's Timon is the meerkat basically. So this is all about my project. Thank you so much.